first statement says SR2 plus is larger than SR. So let's just think about normal SR. Let's just give it arbitrary size like that. If you start taking away electrons, that's sort of pulling away out of this electron cloud. So SR plus would be smaller than that, and then SR2 plus would be even smaller than that. So looking at the sizes, SR2 plus is not larger, it's smaller than. So this would be a false statement. The second statement says Cl has a smaller ionization energy than Cl minus. So again, I usually kind of think of it in terms of relative size. So if Cl looks like this, where there is a positive nucleus and then sort of an electron cloud around it, Cl minus has even more electrons, so it's going to end up bigger. Ionization energy refers to the energy to pluck out an electron. So it's going to be easier to pluck it out of something big where it's further from the positive nucleus. So when it's easier to remove an electron, that's going to be a smaller ionization energy. So the statement Cl is going to have the larger ionization energy because Cl minus is going to have the smaller one. So this statement, as it's written, was false. The third statement is Kr has a more exothermic electron affinity than Br. So more exothermic, that's basically going to translate to likes receiving an electron more. So the more exothermic it is, the more it enjoys that. So kind of think about if you gave Br an electron to become Br minus versus giving Kr an electron to become Kr minus, which one likes it more? Well, when doing this, Br minus achieves a noble gas configuration. So it does like that. Kr over here, it already has a noble gas. Well, noble gas configuration, it is a noble gas. So it's already pretty much full. It's P6. So if you try to shove another electron in there, it's not going to like it, versus this does like it. So Br is going to have the more exothermic electron affinity. So these are actually flipped like this. So then the statement as it's written was false. The fourth statement says Ca has a larger ionization energy than Ca2+. So again, I usually think of it in terms of relative sizes. So Ca has protons in the middle and then an electron cloud. If you start taking away electrons, you're kind of pulling out of this electron cloud. So Ca2+ is going to be smaller. So if we're thinking about ionization energy, which is the energy to remove an electron, it's going to be easier to pull an electron out from the bigger cloud than it is from the very small cloud. So when it's easier to remove, it has a smaller ionization energy. So we decided Ca has a smaller IE, but then this statement says larger. So the statement as written is going to be false. Fifth statement says Br is smaller than Br minus. So let's think about Br's got protons and an electron cloud, and then Br minus has even more electrons. So we're going to add to that cloud, and it's going to be bigger. So the statement Br is smaller, that is true. And that's going to be our true statement.